Let's solve some questions on section midpoint formula and equation of a line. Now these two chapters are interrelated, and there are many questions which were asked where you have to apply concepts from both the chapters. Now the first question is saying that the centroid of a triangle ABC is G 6, 7 if the coordinates of the vertices A, B and C are these three, where this A is unknown. They're asking to find that value of A, the missing A. Now the concept of centroid of a triangle is that if we have any triangle, any kind of triangle ABC, the intersection of all the three medians will be centroid. So if I join the median, let's say this is AD, D is the midpoint of BC, then suppose if I had this BE, E is the midpoint of AC, and then if I have this, F is the midpoint of AB, then these are the three medians and all of them intersect at a common point. Let's say it is G, and G is known as the centroid. Now there is a direct formula for centroid of a triangle. If the vertices are coordinates x1, y1, x2, y2 and x3, y3, then the coordinates of the centroid G will be the average of the x coordinates and the average of the y coordinates of the vertices. So average of the x coordinates will be x1 plus x2 plus x3 divided by 3, and the average of y coordinates will be y1 plus y2 plus y3 divided by 3. Now in this question, the centroid coordinates are already given. So suppose the x coordinate of the centroid is 6. So if I just focus on the x coordinates, and anyway the missing value is the x coordinate of vertex A. So if I only focus on the x coordinates, I will say that x coordinate of A is this unknown A, plus x coordinate of B is 7, plus x coordinate of C is 5 whole divided by 3. This must be equal to the x coordinate of the centroid, which is 6. So if I just solve this as an equation, I will be able to get the value of A. So we have, if I move the 3 to the other side, it will be 6 into 3, 18. So A plus 7 plus 5 is 12, that is equal to 18. So that means A value will be 18 minus 12, that is 6. So A equals to 6, we have option B, that is correct. Moving ahead. Now this question is based on midpoint. Given that point M is 2, B, this is the midpoint of the line segment joining P, A, 7 and Q, 6, 5. We have to find the values of A and B. So we can just do a rough figure saying that we have point P, A, 7 and point Q, which is 6, 5, and point M is the midpoint. So let's say this is point M, coordinates 2, B. So it's the midpoint of the line segment, or it's the ratio 1:1. So if I apply midpoint formula, I will be able to get the coordinates of the midpoint M. So looking at the x coordinate of the midpoint, which is 2, I know that the coordinate for the midpoint will be the average of the x coordinates of the endpoints. The endpoints are P and Q. So I can say that the midpoint is M, which is 2, B. So if I look at the x coordinate, I am expecting that the x1 plus x2 by 2 will give me the x coordinate. So that should be equals to the x coordinate which I see 2 for the midpoint M. So that means I have the first coordinate, the first point P has x coordinate A. So A plus the x coordinate of point Q is 6 divided by 2 must be equal to 2. So just solve this as an equation. A plus 6 will be 2 into 2, 4. That means A will be equal to 4 minus 6, that is minus 2. And then we want to find the value of B. B is the y coordinate of point M. So looking at the y coordinate of point M, I am expecting y1 plus y2 divided by 2, and that should be equal to the y coordinate of point M, which is equal to B. Now y1 and y2 are the y coordinates of point P and point Q. So point P has y coordinate 7, Q has y coordinate 5. So 7 plus 5 by 2 should be the value of B. 7 plus 5 is 12, 12 by 2 is 6. So I am expecting B equals to 6. So A equal to minus 2 and B equal to 6 is the answer to this question. Moving ahead to the next question. They're asking, find the ratio in which the x-axis divides internally the line joining points A 6, minus 4 and B minus 3, 8. So we have to apply section formula to find the required ratio. So we will draw a rough figure. Point A 6, minus 4, point B minus 3, 8. We don't really need to plot these points exactly how they are located on the xy plane. We can just draw a horizontal line for our understanding right now. Now suppose the x-axis will be dividing this line segment. So x-axis is passing through somewhere in between the line segment A and B. So let's say the point of intersection of the line segment AB and the x-axis, it's happening at, let's say, some point here, which is P. Now remember that this point P is lying on the x-axis. So any point lying on the x-axis will have the y coordinate always 0. We already know this. So let's say the point P have coordinates x, 0, some x coordinate, but the y coordinate will definitely be 0. So we will have to specify that first, that let P x, 0 be the point of intersection of the line segment AB and the x-axis. Okay, that makes sense. Now we have to find the ratio in which the division is happening. They are asking the ratio AP is to BP. This ratio is what? Now either I can assume the ratio to be M1 is to M2, or I can also assume the ratio to be K is to 1. So let the ratio AP is to BP equals to K is to 1. So this is K, this is 1. The rough figure will really help me apply the section formula correctly. So it's always a good practice to do that. Now according to section formula, if the line segment AB is being divided by some point P in the ratio K is to 1, then the x and y coordinates of that point in between we'll be able to figure out. So focusing on the x coordinate, an x coordinate of P is already, I'm assuming, to be x. So I will say that the section formula is m1 x2 plus m2 x1 divided by m1 plus m2. This will give the x coordinate of the point in between. So if I just substitute the values, I will get, and it's very easy to substitute if I have the rough figure like this. We will have this part of the ratio, that is k, multiplied by the opposite x coordinate, which is minus 3. So I will have minus 3k plus 1 multiplied by the other x coordinate on the other side, plus 1 into 6 is 6, divided by the sum of the parts of the ratio k plus 1, and that is the x coordinate of the point in between, that is point P, and here the x coordinate is x. So you can see that this equation, I am trying to find the value of k, but here there is another unknown x. So this will not exactly help me get the ratio. So instead of the x coordinate, maybe I will look at the y coordinate. because the y coordinate is already known. So y coordinate is 0. So instead of the x coordinate, let's just focus on the y coordinate. Is a similar formula for the y coordinate. We will have m1 y2 plus m2 y1 divided by m1 plus m2. This will give me the y coordinate of the point in between. So I already know the y coordinates of the two endpoints and even the point in between. So we have k multiplied by the y coordinate of that point, which is 8. So we will have 8k plus 1 multiplied by this y coordinate, which is minus 4. So this is 8k minus 4 divided by k plus 1, and that is equal to the y coordinate of this point, which is 0. Alright, then if I move k plus 1 to the other side, it's 0 multiplied by k plus 1, that will be 0. That means 8k minus 4 is 0, and that means 8k equals to 4, and that gives me k equal to 4 by 8, that is 1 by 2. So the ratio that I assumed was k is to 1, so the required ratio is 1 by 2 is to 1, but I don't want any fraction in any part of my ratio. So if I multiply both parts with 2, I will get the ratio as 1 is to 2. So the x-axis divides the line segment AB in the ratio 1 is to 2.